Hi, yeah, thanks for being here. I'm going to tell you about my project Decodoku, and the paper is called Getting the Public Involved in Quantum Error Correction. So this was done in collaboration with the NCCR QCIT, which funds quantum technology research in Switzerland. So the background behind this, I won't tell you too much about the background, but quantum computing is this new architecture for computing which is different from our current computers and which will be able to solve certain problems much faster. The way it works is to use, instead of voltages or transistors within a chip, it uses quantum systems. And quantum systems are very small and very susceptible to small effects. So they're very fragile and very noisy, and so we need techniques to remove the effects of noise. This is going to be done by what are called quantum error correcting codes. So basically you take all of your quantum things you're building your computer about, you place them on a grid and you tell them to obey certain rules. Then you keep checking up to see if these rules are obeyed. And if they are, that's great. If they're not, then it's a signal that something's gone wrong. It's a trace that there has been an error. So because you place it out on a grid, then you get these clues on a grid, and they just take the form of numbers. So basically, quantum error correction is a grid-based puzzle game where you have some numbers on a grid and you have to solve a puzzle in order to work out how best to deal with your quantum errors. So because it's basically a puzzle game, we made it as a game and then offered it in various platforms, including iOS and Android, and it's called Decodoku, because the scientific problem behind solving these puzzles is called decoding, and it's a puzzle game like Sudoku, so we call it Decodoku. There's two main aims of this research. One is to give the public a taste of what we do in quantum research. So actually another aspect of this is also to be a starting point for further study, because there's a lot of people who seem to be interested in the idea of quantum computing, but they don't know where to start finding out about it. But we've got a nice little game which has background behind it where they can learn just about this specific part of quantum computation, get very hands-on with it, and also use that as a starting point for learning about other things. But one aspect of the project is also to let them become a quantum researcher too. So let them actually do some research themselves and have it contribute to the development of quantum computation. So the first two aims we were quite successful at. The third one we were less successful at, so I'm going to meditate upon that one in this talk. This is a citizen science game, and citizen science games are very common. They typically use players to do some simple in-game task, and that task generates data. The data is then sent back to the people who made the game, and they do some science with it. What we wanted to do was different. We didn't want to... The data that we could get off players is not actually that interesting. What we need to know is the strategy that the players have done. We need them to reflect upon their strategy and then report it to us. So this is quite a hard task that we're setting them, but it's not more than what players often do. So in the short paper, I cite a paper about World of Warcraft, where people on the forums of World of Warcraft are discussing and investigating the world of Warcraft to try and work out how it works and therefore to be better players. Also last week, the game Freeze, which is a popular mobile game, was completed, and it was completed by this guy who's very interested in the strategy, and he posts videos of himself playing. And he got huge scores. So if he did that, but for my game, then he would be doing science. So we need some way to tell the players how they can contribute, and we originally imagined that this could be through Let's Plays. So Let's Plays are very popular, where people video themselves playing a game, discuss themselves playing it, and so it's a very good way of transmitting information about how someone is thinking about playing the game. And it's very popular, so we thought that people would take up this. But the kind of people who typically like to do Let's Plays don't really like to do them about puzzle games, except for that guy with Freeze. And the kind of people that might want to contribute, they don't really think of themselves as YouTube contributors, and really adding the voice to a video and then putting it on the internet is very off-putting to many people. So even though Let's Plays are very popular among a class of people, they're not popular among the right class of people. So what evolved was that people preferred to make a video of themselves playing a game, post it on the internet, and then via our message board on Reddit, they would describe their game and other players would ask questions. So it was video, silent video, and text is what we had in the early days. In order to try and help a wider class of people, we created save files, which are a complete record of the game, and they can be commented on to explain the method. So it's basically a video of you playing the game, but in the form of a spreadsheet, which is much more fun, right? So this was more accessible to some people because they didn't have to engage with any videos. And it also, at one point during the project, we also allowed players to send us the raw data, and then we would look at it and then ask them questions. So even though we wanted to encourage people to have this self-reflection themselves, because it was hard to make that, we were doing it in a more guided way, where they send in their data, but that's not the end of the story. It just starts a conversation between us and the player. So doing so did get some good results, but it didn't fulfill the main aim of the project, which was just to give some software in which people could do their own scientific research and have a bit of fun and do something useful. So what we've done to improve is also have an interactive tutorial mode in the last few months. So this takes the methods of last year's players and then makes them into a bot, and then that bot suggests moves to the current players, and that can train them how to play the game. It can also provide a reference point for their self-reflection on trying to work out what their method is, because they can think, well, am I doing the same thing that the bot suggests, or am I doing something different, and why is that? And it also provides an easier way for them to maybe explain their method, because they can say, oh, sometimes the bot does that, and that's stupid, so I do something different, and this is why. In the end, we've gotten a few very high quality results. So it's like having a few master's students doing a project on quantum error correction with me, but some of those master students were in New Zealand and some were in, New Zealand is obviously the furthest away. I shouldn't have started with that one. So we've got people who didn't have a scientific background from around the world, and they were doing sort of research on the same sort of a level as a master's student on this specific project. But we learned the hard way that we really needed to provide a lot of resources and think through how people might want to interact with this part of the game, this one where they have to self-reflect and then report to us, and provide resources for many different people to do it in many different ways, and to really guide the player instead of just saying, here's something you can use to do some research, have fun, and expect it to be in the way that I expected, which was in the form of Let's Plays. So we hope that in the future, when there are more citizen science games that don't just have the player doing a simple in-game task, but want them to be more actively involved in what's going on and do some of the processing and the sciencey bits themselves, that they can learn from us. And the take-home message is, that you should work out many different types of players, maybe do some research, research of potential players beforehand, which we really should have done, see how people feel they would like to engage. Okay, so that's my take-home message, and then I'm just going to tell you quickly what I'm doing now. Well, Decodoku is still going on, so if you want to do some quantum error correction research, then you can start today. But we are also having a new project in future, which is to make games that run on quantum computers. So quantum computers, as I said, this new kind of computer, only prototype devices exist at the moment, and they cost millions of units of currency, but let's take those cutting-edge pieces of technology and play games with them. So I've got some ideas about what would be interesting about this, but if you are interested, I'd also love to hear your ideas about what we could do with quantum games. Okay, so that's it from me. Thank you for listening.
Thanks a lot, James. Some questions?
Thank you for the great talk. Correct me if I'm wrong. So you developed this game so that you could better understand how people go about solving quantum problems? Was that the purpose of the citizen science aspect of this game?
Yeah, well, there's many different ways of doing quantum error correction, and some of them we have fancy algorithms for that do awesome, but some of them, even our methods as professional scientists are very heuristic. So we thought this is a corner of cutting-edge science that we don't actually do any better than a normal person, so let's get them involved.
Okay, yeah, that's the link that I missed. I was trying to understand why it is that the layman, like the process of a layman solving those problems would be interesting to you. It also seems to me like you might want to consider talking with maybe cognitive psychologists. It sounds like these sorts of problem-solving stuff might be things that cognitive psychology people would be interested in.
Yeah, could be.
Thank you.
Thank you.
Maybe another short question? If not, I just have one. How did you reach your audience? Did you share the game on a platform or just on the internet?
What was that, sorry? There was some noise as you stepped down the stairs. I didn't hear
how did you reach your audience? Did you share the game on different platforms or?
Yeah, so it was mostly through Reddit, which is this online discussion board, which is really popular. And that's where we had our community, which discussed the game, and so mostly I was just active around Reddit.
Okay.
Even though you're not supposed to self-promote, I was staying within the rules-ish.
Thanks a lot, James. Thanks for this very interesting speech. The next speech will be by Denise Souter-Widmer from Geneva University and TECFA and FAPSE. And she studied a serious game about mathematics and especially algebra. This was a study made on students in secondary school, and she studied the motivation in learning processes.